Okay, so the first things we're gonna talk about really with our circular functions is, yeah, we're using the same rules that we use in trigonometry, sine, cosine, and tan, but we're going to sort of define them and tell you what they measure. Okay. Now, the first thing we need to talk about is the fact that the angles that we measure with our trig ratios can be measured in two ways. You can have an angle in degrees and you can have an angle in radians. Okay. Now, a radian measure, I think the easiest way to describe a radian measure is the distance around the unit circle. Okay, so there's a circle of radius 1. So if you like, that distance around to there, well, that's the same as 90 degrees. And the distance around the outside of the circle, that's the equivalent radian measure. All the way around to there, well, that's obviously 180 degrees. And that's the same as the half a circumference of a circle. All the way around, okay, so that's the same as 360 degrees, and it's the circumference of a circle. So what we do is we start with 360 degrees, and that's the same as 2 pi r, which in this case, because the radius is 1, so we say that 360 degrees is the equivalent of 2 pi radians, and we sort of put a little c to measure radians, okay? If I divide by 2, that means 180 degrees is the same as pi radians. Divide by 2 again if you like. 90 degrees is equal to pi on 2 radians. Divide 180 by 3, I get 60 degrees. That's the same as pi on 3 radians. 180 divided by 4 is the same as 45 degrees. That's the same as pi on 4 radians, etc. So the other one, 180 divided by 6 is 30 degrees, and that's the equivalent of pi on 6 radians. So they're the key values. They're the key radian measures that you need to know sort of off the top of your head. So if I say to you, right, pi on 3, in your head you might do 180 over 3, which is 60, so it's 60 degrees. All right. The other thing to take note of is that when we measure our angles, okay, for those that have done a little bit of general or some bearing questions, we normally start from north and work our way around. Well, in circular functions, we always start from the x-axis and make our way around there. Okay, so that's 0 degrees there. Around 90 degrees, that's 90 degrees. That's 180 degrees. And down here is 270 degrees. And we come back to 360. Okay, if I go in the opposite direction, that's the same as negative 90 degrees, negative 180 degrees, negative 270 degrees. All right, so anti-clockwise is positive, clockwise is negative. To convert angles to from degrees to radians and radians to degrees, basically we multiply by pi on 180 or 180 over pi. So if I want to convert degrees to radians, I multiply my degree measurement by 100 by pi times 180. And if I want to convert from radians to degrees, I multiply by 180 at pi. So multiply by 180 on pi or multiply by pi over 180. So just down in here, convert the following. So I guess a couple of quick ones first. If I want to work with 60 degrees, multiply by pi on 180, well, 60 goes into 180 3 times, that's pi on 3. The other way to think about it is, 180 over 3 is equal to 60. So 135 degrees multiplied by pi on 180, and we'll end up with, some of these are probably over the page. What's a good number that goes into both of those? 45, actually. 45 goes into 135 3 times, 45 into 180 4 times. That's the same as 3 pi on 4. Okay, I think you get the idea. So if I come in here, let's multiply by 1 180 over pi. So the pi symbols cancel. 8 and 180, we could try and find common factors if we can. So 4 will go into both of those. 8 probably goes into both. Maybe not, but we'll go with 4 anyway. So 4 goes into 8 twice. 4 goes into 180. Let's see, 40 times is 160. So it's going to be 45, isn't it? 45 times. So we end up with 5 times 45 on 2, which is equal to, and what's that, 225 on 2, which is 112.5 degrees. So a messy number, but that's okay. If I want to convert this into degrees, multiply by 180 over pi. Pi's cancel. I just get left with 0.6 times 180. 6 18s are 108, so it's 108 degrees. All right. If I want to convert these radians into degrees, the little symbol is a radian. So typically, to remember, I divide by 180 over pi. Times by 180 over pi. So 3.4, well, if you think about 3.4, it's just a smidgen bigger than 3.14159, which is pi. So this answer is just a little bit bigger than 180 degrees. And since I don't have it, what was it equal to? It was 194.806 degrees. So 194.8 degrees, 0.5. So a half times 180 over pi is the same as 90 over pi, which is equal to 28.64 degrees. Similarly, and we just sort of spoke about some of these ones, if I want to convert degrees into radians, let's just make it a bit bigger. I need to multiply by pi over 180. So zeros will cancel, it'll give me 15 over 18, and 3 goes into both of those. 3 into 15 goes 5 times. 3 into 18 goes 6 times, so it's 5 pi on 6. 80 times pi on 180. Again, the zeros cancel out, so I get 8 on 18, which is the same as 4 on 9, which is equal to 4 pi on 9. If I want to convert these degrees and minutes into radians, I'm going to have to use my CAS for that. So type it into your calculator, 46 degrees, 56 minutes. So I'll show you the output, but basically, if you go using your CAS times by pi on 180 is equal to 0.819 radians. Similarly, just 175.78 times pi over 180, well, 175 over 180 is nearly 1. So our answer should be close to pi, which is equal to 3.07 radians. All right. So at this early point in time, it's just really using our conversions, times by pi on 180 or divide by 180 or times by 180 on pi. Okay.